In this video, we'll see the equation of a circle. It's been given to us the center of a circle is h comma k. And let's take any point on this circle as x comma y, which is the general point on this circle. We know this moving point, let's call it P. X comma y, wherever it moves on the circumference, the distance from O to P, as P moves along on this circumference, it remains same or the constant. So from here, we can write x minus h to the whole square plus y minus k to the whole square equals to r square. That's the distance formula. That's the distance formula. That is the distance between OP. OP is equals to R. R, in the other words, we can say OP square equals to R square. So here, if I open this brackets, we have x square plus h square minus 2xh plus y square plus k square minus 2ky equals r square. Let's keep all the x terms together. Minus of 2xh, then plus y square minus of 2ky. Let's keep all the constant terms together, h square plus k square minus r square. Since h, k, and r are the constant values, let's use them as one constant and put that value as c. Now here I have further x square plus y square. Let's replace minus h with g and minus k with h. And let's replace minus k with f. So this becomes plus 2gx plus 2fy plus c equals to 0. So if I need to make it a perfect square, so what I have, x square plus 2gx, and I see the coefficient of x, that's 2g, make it half. Half of 2g gives me g square, that term. And this term, g square, I'm going to add on both the sides. Then further, I deal with the y terms. It's y square plus 2fy. Coefficient of y is 2f. Half of it is f, and the squared value becomes f square. I add on both the sides. Take this plus c on the other side. That makes it minus c. So these first three terms becomes x plus g to the whole square. And this term becomes y plus f to the whole squared value. And this becomes g square plus f square minus c. Comparing with the general equation in this form, which has been used taken by distance formula, which has been taken by using distance formula, it becomes my center as minus g and minus f. And my radius becomes the root value of g square plus f square minus c. Let's further discuss more about the equation of the circle. So here, what do we see the following properties? That the equation of a circle, it's a second degree equation in x and y. Also, it contains no term of x into y, the product of x, y. Third, our observation is that the coefficient of x square will be equals to coefficient of y squared term. Let's further note that if the value of g square plus f square minus c equals 0, then the above equation represents a point circle. If this value g square plus f square minus c is 0 and root of 0 is 0, then this equation 1 is a point circle. Secondly, let's note if g square plus f square minus c is less than 0, then the above equation doesn't represent a circle. Then let's take one example. X square plus y square minus of 4x plus 10y minus 21 equals 0. This is the given equation of a circle and we need to find out the center and radius of the circle. So let's first compare with the general equation that we have just taken it out. X square plus y square plus 2gx plus 2fy minus plus c equals 0. On comparing the coefficient of x, we have 2g equals minus 4 and here 2f equals 10, which further implies g as minus 2 and f equals 5 and so here the center is minus g comma minus f, which becomes minus of g makes it plus 2 and minus 5. That becomes the center of this given equation of the circle. And let's evaluate radius now, which is root of g square minus 2 square makes it 4, 5 square makes it 5 square, 25. C is in this case minus of 21, so minus of minus 21 makes it plus 21, which further makes it 50. That's 5 root 2 units is the radius of the circle. That's how we can evaluate the center and radius of the circle if the equation is given in this form. That is x square plus y square plus 2gx plus 2fy plus c equals to 0. That's all in this video. Thank you so much.